Today we're going to be talking about scaling Drupal multi-sites deployments with GitHub Actions. So I hope you enjoyed your lunch and you're ready for some GitHub Actions action. My name is Emerson Reis. I'm a senior DevOps engineer at Zucha. I came all the way from Brazil to give this talk, so hope you enjoy it. I've been working with Drupal for about 8 years now, and I'm a triple certified on Drupal 8, 9, and 10. Haven't done 11 yet. Hopefully soon. But yeah, so let's get started. So first of all, a bit about Drupal multi-sites. Who doesn't know about Drupal multi-sites here? Can you raise your hands? Yeah, just one person. Just a quick overview. So when you create a Drupal site, you have one site, which is kind of your default site. And then Drupal gives you the option to have this called multi-sites. You basically share the same code base across all of them, but you have separate databases, config, and so on, files. So that's what Drupal multi-sites is. So there are certain use cases where you want to have a Drupal multi-site instead of a separate sites, you know. I'm going to talk about how we deploy them and challenges about deploying Drupal multi-sites. So what are the challenges really about deploying Drupal multi-sites? Because if you think about, I just said that they share the same code base. So when you deploy a Drupal multi-site or a Drupal normal site, you just honestly just need to update the code, right? Just git pull, whatever, and it depends on the infrastructure, how you have your CI/CD set up. But the main challenge really about Drupal multi-sites is kind of the post-deployment phase. Because I mean, nowadays we already need to be running just deploy, which runs cache rebuild, database updates, and config import. And well, these things can take time. Like if you think about a very quick one, it can take 1 minute, 2 minutes to finish everything. Depends really on what you're deploying, obviously. But this can take time. And when you're working with a Drupal multi-site setup, these things can, get out of hand. And why is that? Because we had this use case of a system having about 600 multi-sites. So now we're not talking about taking like 10 multi-sites or 5 multi-sites and running just deploy for each of them, which would take 10 minutes, which is fine. You're okay to wait 10 minutes for deployment to finish. But if you're talking about 600 sites, and let's say each drush command takes 1 minute to finish, you have to wait 10 hours for your deployment to finish. And that's not good. Like, you can't really wait 10 hours for something to be released. That's unacceptable. So there are some ways to approach this problem, and I'm gonna be showing you how we started at the beginning with the very simplistic approach, and then we'll go from there trying to solve each problems that we encounter. Oh, sorry. So this is kind of the initial approach. Also, just who here has never worked with GitHub Actions? Nobody? Perfect. You? Maybe. So yeah, we have a file definition of our workflow with GitHub Actions, and I'm not gonna go deep into how GitHub Actions work or the beginning of this setup. It's mostly about actual drush commands, because deploying the code really rely on how your CI/CD is set up, and every project has a different requirement. So once you deploy your code, then we have here the drush deploy job definition. And it really is just a sequential steps running just deploy to each site really that you have. And this is a very simple approach and easy to understand, easy to manage. Everybody looking at this file will know what's going on. You're just running just deploy for all the sites you have. But obviously there are issues with this. And the first one is maintenance, because having 600 sites means that you're always adding new sites, you're deleting old sites, you're updating existing sites. So you need to update this workflow file whenever something like that happens. And also the execution time, because like I said, 600 sites would take 10 hours to finish if you're talking about 1 minute to finish the just deploy command. But yeah, of course, this is very easy to implement, very quick, complexity low, as low as it can be. But let's try for the next approach to sort out this execution time, because this is the main problem here. Like, we don't really want to wait 10 hours for deployment to finish. So what we can do with GitHub Actions is we can use what they call matrix strategy. So what this does is it allows you to define variables that will have different values, and GitHub will use these different values and create the jobs dynamically. So in this example, we have the site variable. It's just almost like a vector, not a matrix, but you can have multiple variables as well if you want, like to run different PHP versions or anything like that. In this case, you only have this site variable with a list of all the sites. So we still have these sites here hard-coded in this workflow file. So we're not really worried about the maintenance now. But what this is going to do is GitHub will read this file and will create a separate job for each value possible that you defined. So instead of having one job to just deploy, you have, like in this example, 4 jobs, or in the example of 600 sites, you have 600 jobs spun up. And the reason this is better is because jobs can run in parallel. So by definition, all jobs that you define in your workflow file will run in parallel. You can configure them to run sequentially with the needs key. You can see on line 18, have a needs key for the deploy code. So this will wait until the deploy code job finishes before it starts. And the other way you can have things running sequentially is, as I had in the other example, which is just sequential steps, really. So what GitHub does is it has this thing called runners, and each runner will pick up a job that is ready to be executed and run the job. So if you set up it like this with 600 sites, and there are 600 runners available to pick up jobs, in an ideal world, this would take 1 minute to finish instead of the 10 hours. Obviously, this is completely ideal world scenario. It will never happen. You might have to wait a few minutes before all the runners pick all the jobs that GitHub created. But anyway, you'll still be a lot faster than 10 hours. Give it like 10 minutes or something like that, which is very good. So we fixed the execution time issue that we had with the other approach. We still have the maintenance issue that we discussed, had to manually update all the sites. But then we kind of created 2 new problems here. The first one being the cost, because GitHub Actions cost money. They give you some free tier to use, which is very good, but they bill you by the minute that the runner takes to finish the job. So in this scenario, if they take 1 minute, you have 600 minutes, like 10 hours to pay. But the difference here between the other approach and this one is because GitHub bills you by the minute rounded up by job. So in the other one, you're running one job for all the sites. So you would have kind of actually 600 minutes. In this case, if the jobs take 1 minute and 1 second, you have a bill 2 minutes and you pay, yes, you pay for 1,200 minutes instead of 600. So this becomes a bit of a problem unless you have the money. If you have the money, you pay for it. But most of us usually have a limited budget, so we kind of have to find solutions for it. We'll get to that. But the other problem we're going to see here with this approach is the resource usage, because imagine you're running 600 trust deploys on your servers. This is going to cost you because it's going to use all your CPU and memory, unless you have a very big server or you have a separate container to run these commands. This can be a problem for you. So how do we, just to show you an example here, this is a real world example. The whole workflow run took 6 minutes to finish, but GitHub billed us 54. So this is more than 3 times the actual time it took. So this can actually add up a lot. But let's go back to the issue about resource. We don't want 600 commands running at the same time and potentially bringing the site down because your database is under stress. So what GitHub allows us to do is define how many jobs we want to run in parallel at the same time. Obviously. So, and for this one, you really have to just try it out. Like, for example, we have 600 sites. Let's run 10 at a time, and then we have like 60 separate runs. So you just have to play with the number and see how much your server is going to cope with it, and also a balance between how long you want to wait for the deployment to finish, and maybe you just want to increase your resource from the servers to be able to run these deployments. But this will give you the solution to not bring your site down just because of deployment. Like I said, we fixed the execution time. Now we fixed the low resource usage, well, the big resource usage that we had before. We still have the maintenance cost though, because it is a burden to have to always keep updating the workflow file whenever someone creates a new multi-site. And if you think about it, if you have all these multi-sites, they have to be stored somewhere. You need a list. Somewhere there must be a list of all the sites. So why do you need to copy this list over to this workflow file? You have to find a way to create this on demand. And this is how you can do it. You use this approach of output from GitHub Actions. You have a separate job only to get the list of the sites. That's the only goal of this job. And then it gets the list and it saves it as an output. And the reason it needs to go to an output is because, like I said, like each job will be picked up by a different runner. They'll never, well, unless you have a very lucky, they'll never be picked up by the same runner. So the runner that is running the other job will never know what happened in the previous one. But then GitHub allows you to use these outputs, and these outputs will be available to you in the other jobs. And I'm not going to go into how you find these sites, because it will really depend on your situation. You might have an API, you can respond with a JSON with the files, or you might just SSH into the server and list all the folders that you have there, because that's basically the list of sites. Whatever you do, as long as you set the output that can be used by the other job, you're set. Then you can see on line 38, which is last line, we just create the variables that we had before the list from the JSON that we had as an output from the previous job. And everything else stays the same. So now we fixed the issue. We don't need to keep updating the workflow file anymore. But we still have the cost issue here. You're still paying lots of money to GitHub because they're rounding up our minutes. And the solution to this might not be an actual solution because it always comes down to a balance between how much you want to pay in maintenance and how much you want to pay to not do anything at all. Because what GitHub does, it allows you to self-host your own runners, which is very good. And they don't charge anything at all for you. No minutes, zero. So if you have a team that is able to maintain self-hosted runners, that would be the perfect solution for you. Obviously, if you don't have already a server for that purpose, you would need to get a server, and that server will cost money for running on AWS, Google Cloud, whatever, you name it. You have to pay for that as well. So you need to balance between how much you will be paying GitHub and how much you'll be paying for this self-hosted runner. It might be just a matter of choosing who you want to pay. But maybe your team already have a server that they can set up multiple runners. But it really is a balance. And like I said, you need to think about how much you're paying for the actual server that you're hosting the runners, but also the burden of maintaining these runners, because they need to monitor them, make sure they're running. They need to keep them up to date. And you're gonna need a team or someone that will be able to do that. And if your team is already burned out with a lot of things to do, maybe that's not the best approach. You might just want to pay GitHub anyway. Maybe some of you might be thinking, what if I just use the first approach, but I write a script that can actually run these things in parallel instead of leveraging the GitHub Actions matrix strategy? You could do that, and that's actually what we had at some point. But the real problem with that is, first of all, you're not leveraging what you're paying for, because this is what you see on a run. You can see for each site, you have a different view, and you can quickly see that that site failed, and quickly click on it and see the logs, see everything that ran, everything that failed, and quickly identify why and fix it. If you had a custom script, doing this wouldn't be as simple as that. You need to build a lot of things on top of it just to be able to actually monitor where it failed and why it failed. So yeah, you can do it. It's doable. It will be cheaper because you'll be running only one job. But yeah, you're not leveraging the results of using the GitHub Actions. While that's very good, perfect, but in our case with 600 sites, GitHub has this limitation of only being able to create 256 jobs from a matrix. So we had to do chunk-based approach, which basically gets the list of the sites that we had, like 600s, and then creates chunks of 256 sites. And then from these chunks, it creates the jobs for each site to run Drush deploy. So it's just an example how we did it. It's just a mix of the shell script and some GitHub Actions maneuvers. So it's using a matrix strategy to create the chunks, and then the chunks are used again to create the jobs like we used before. So yeah. And well, that was it actually. If you want to find me on Instagram or LinkedIn, you can read the QR code. Does anybody have any questions? Yeah, go on.
Really good. So two things I want to ask, like the runner thing that you mentioned. It's a little bit out of scope for the presentation, but what is involved to set up our form version? And the second one is you mentioned each of the sites are separate database as well. I was thinking like if it's the same database, then probably you would either run in a single container or like something like that, then that means in a way that all the processing powers are going to one place. But then if it's a separate database, then you might be running multiple containers for each site. I'm just wondering what the setup would look like for Drupal. Like, I understand the code base is single code base, but the databases are running in different places, and that means each site's codes you're deploying in different containers or a single container connecting to different database containers.
Can you just repeat the first question? Sorry.
First one is what it takes to run runners, like the setup of runners, because I mean I can understand as the running site, like some of the sites that we work on, we build are as part of the deploy step or build step, we create a container and we push it to a registry for the git commit hash, so that we build only on one environment and the same container can be pushed to staging prod, so that we don't have to rebuild over and over. And you gave a good example. Deployment takes less time, but then compulsory install, if you need to run, that takes a long time. So yeah, like kind of the setup wise, how you do it.
So first of all, how you set up the runners. I mean, you have plenty of ways to do it. Well, basically how it works is GitHub gives you these instructions that you run on whatever your server or Docker container, and it's just really a service running on the server. Or if you have like just a Docker container, multiple Docker containers running, each one of them being a runner, and then you connect your account. Then it I think it keeps pulling the GitHub API to find which jobs are ready to be executed, and it picks them up and run them. I mean, it's an interesting question, but I think the focus here is more about scaling the Drush commands rather than how you're actually deploying this code. Because I think, yeah, some people might not even be using containers, and or like I said, if you have a container, your question is like, I don't know really. Like, I don't know if the database is the same container, just separate container. I just know how the Drupal works. You have separate databases. I mean, I don't mean database instances, just database. You might be running on the same shared database server, so to speak, but just separate database entities within like MySQL, for example. So I mean, I'm sorry. Yeah, does that make sense? Yeah, sorry.
Any other questions?
That's a good question about the concurrency of settings. So you mentioned that only round up the execution time to the nearest, well, to round it up to the initial. And once you've chunked the sites, is there any way to sort of change the chunks based on how long the execution time is? So can you kind of have a feedback loop where the chunks change if there's an amount of execution time left in that particular section, or do you have to kind of define all those variables up front before it starts doing the execution?
I'm not sure if I understood your question. So, like you said, how much time you have left? What do you mean?
So for example, if you have a batch of 5 sites and
Yes.
you've just gone over the minute boundary, can you put some sort of conditional logic in there to then continue using that to pick up an additional site within that chunk, rather than just splitting it into like a number of sites?
Yeah, I mean, from my understanding, I don't think so. So because these are just jobs that are gonna be created dynamically on the fly. So each one of them will be built separately. Like in the example I showed you, I only showed you the actual final result, which is 70 minutes, or 60 minutes, sorry, and then 54 minutes build. But they actually do that by job. So if a job took 1 minute, it will be built 1 minute. If a job took 1 minute and 30 seconds, it will be built for 2 minutes. So at the job, when you're running the job, you don't really have that information.
You'll be able to build one, right? Imagine we can have a shell script that measures the time, and then the shell script round up the time, and then if the time is less than whatever the number, then you add more stuff into it instead of giving an explicit list of sites.
We could do it for future runs.
Yeah.
The matrix is already being assessed for that particular run.
Yeah.
If you record it for future runs, then assuming
Yeah, so like there were.
Maximizing the relative time you pay for by changing the number of things and doing each run dynamically.
Yeah, there's definitely room for improvement on trying to find ways to save money, which is always a nice challenge, interesting challenge. Thank you for your question.
Yeah, with the batch approach, is there a way to see specifically what failed inside that batch? Like say there's an error in like the batch 13 to 35, would you be able to pinpoint where that occurred, or is it just, oh, that batch failed and then something like wrong inside it, so you have to rerun everything inside it individually or something like that?
When you say batch, do you mean the chunk?
Yeah.
Yeah. Okay. Yeah. No, you have. Let me just go back here to show you. So what you see with the chunk-based approach is this is the first chunk. Then you have a second one here, and then a third and the fourth. They're all gonna be here, just like this one. So you'll be able to tell which ones failed right away. Does that? Yes. Right. Right. Thank you very much for your time.